Okay. So the first part of 2.6 that we're going to go through is absolute value functions. Now, I will also tell you that a lot of 2.6 is graphing. There's a lot of graphing involved. And so if you feel good about using slope-intercept form and putting things on a graph that way, that part of it isn't going to be too bad. All right. But the idea of having a table of values, generating a table of values, writing all that stuff down, it's going to be important. You're going to need to know how to do that. Now, we're just going to start with an example. Okay. So this first example is graph f of x equals the absolute value of 2x minus 4. And then we're going to identify the domain and range. And I know we've struggled a little bit with that idea of domain and range. When we have an equation, we have to look at domain and range a little bit differently. And we're going to continue to look at that. We're going to keep working on that in 2.6 and beyond. So hopefully you will get more and more comfortable with the idea of how to find domain and range from an equation. One thing that's important to know is what the shape of an absolute value graph is. Okay? We're talking about a linear absolute value function. Or an absolute value function, I should say. They are shaped like V's. They can be normal right side up V's, or they can be upside down V's. So when we graph a linear function, the shape will always be some kind of V, whether it's a right side up V or an upside down V. That shape is something you need to know, because that's kind of your target. When you go to graph one of these things, you should end up with a thing that looks like either a V or an upside down V. Every time. And the way we're going to do this is with a table of values. Okay, we're always going to make a table of values for absolute value functions for now. Later on in 2.7, I'm going to show you some ways to maybe get a better idea of what your graph is going to look like. But for now, we're just going to make a table of values. And I would encourage you every time to start off with something easy. Right? And I would start off with the x values. So for me, I want to start with something really basic. Just going to go 0, 1, 2, 3. Okay? And then I grabbed a grid from the internet. You can do the same thing if you want. If you want to use your graph paper on Notability, you can do that as well. That is technically allowed. You can sort of draw your own axes there. All right. And so all we're going to do is we're going to plug these. Now, notice I picked 4 values. One of the things you have to get used to is this idea that you're going to have a lot of points. And I know that in the past with like a line, you only needed a couple points. Well, with these functions that we're going to be looking at in 2.6, you're going to need a lot more than 2 points. So I'm going to start off with these first 4. And you can pick any value for x. It's fine. Might as well pick numbers that are sort of easy. Now, the couple things to think about here. This f of x, we've talked about this. What is that the same as?
Y.
It is the same as y. So you can think of this as the y. I mean, in reality, maybe I should have wrote f of x here instead of y. But we can think about it the same way. When we get to writing domain and range, we'll switch back to f of x. But so when I start, all I'm going to do is I'm going to plug 0 in here. And I'll write the first one out. So I'm taking the absolute value of 2 times 0, and that's all minus 4. So what is 2 times 0?
0.
Absolute value of 0.
0.
Minus 4.
Negative 4.
Negative 4. Okay. So that goes here. And I can plot that point. 0, negative 4. Just like that. Now I do the same thing for 1. So I plug 1 in for x. What do I get out of that?
2.
Would you like to try again?
2 times 1.
Yeah, I want the whole thing. Oh,
Oh.
yeah.
And then 2, and then 2 minus 4 is
Negative 2, there we go. Okay, so then I got another point, 1, negative 2. Okay, and I can plot that. So I'm starting to kind of see the V take shape a little bit, kinda. At least one side of it, right? What do you think the next one's going to be? Without doing any work at all, do you think you know what this number is going to be?
0.
How do you know?
It's linear.
Pattern.
It's a pattern, right? So this one goes up by 2, goes up by 2. Let's verify it. I plug 2 in here. 2 times 2 is 4. Absolute value of 4 is 4 minus 4 is 0. So we're correct. Very good. What's the next one going to be?
6.
2.
Oh, 2.
2. Should be 2. Okay, so I plug 3 in. 2 times 3 is 6. Absolute value of 6 is 6. Minus 4 is 2. And I can plot that. Okay. So, I mean, we generated a couple points, but then we saw a pattern, and that made it a little easier. If you want to plug all the numbers in to verify, you can. But when you start seeing the pattern, bless you, be sure to use it. Save yourself a little time. Now, here's where it gets tricky, okay? Because, and I'm going to just sketch this on here. This is, you don't draw this, right? Bless you. So far I have this, right? We assume it just kind of keeps going up like that, right? The question with the absolute value is, where does it make the turn? Because in order to have a V, it's got to come either back down. So for example, maybe somewhere up here it kind of comes down like this. That might be one example. Or maybe it goes like this. And the truth is, I don't know. You don't know. So at this point, you have to make a choice. You got to make a decision and say, you know what, I probably better pick a point somewhere over. I don't know if I want to keep picking a point over here because it seems like it just keeps going. So, but if it turned around and went down, maybe I should pick like 10 and see what happens with the x and see if it goes down. If I plug 10 in and I get something up here, then I know it's just going to keep going up. So just, let's do that, 10. Let's plug 10 in and just do it in our heads. If I plug 10 in here, what do I get? 20. And then the absolute value 20. So it gives me 16. So if I plug 10 in, I'm going to be way up here somewhere. So that, I mean, just that's a little analysis, right? So it's going to keep going up. So maybe we should go the other way and go over here somewhere and see if it doesn't, because it could keep going down too. That's the other thing. It could keep going down because maybe it doesn't make the turn until over here. So one of the things you have to understand about graphing absolute value functions is you have to be persistent. And this is going to happen in your homework to you. You're going to be like, I keep trying values and it never makes the turn. The thing you have to understand about absolute value functions is they always are V's or upside down V's. It will always make the turn. So you have to be persistent. Maybe you got to take a value way over here to see where it finally makes the turn, okay? Well, for our example, I'm just going to go take a negative. Let's just take -1. I'm going to try to keep it easy on myself and see what happens. Maybe we'll get lucky. If not, I'll have to pick a different value, right? So I go to plug that in, and I get 2 times -1, the absolute value of all that, minus 4. What does that all give me? Okay, all right. So I get the absolute value of -2, which is 2, minus 4, which is -2. So that's where my point is. -1. Did it make a turn? It did. It started going back up again. So we got lucky. Okay. Now, here's the next thing. The thing that we know about absolute value functions in V's is they have what's called bilateral symmetry. You can cut it down the middle and one side will be an absolute mirror reflection of the other side. Okay? You know what else has bilateral symmetry? You maybe heard that in a different class. Do you know? No? In science class, you never heard of bilateral symmetry? Cut your body right down the middle on the outside? Mostly, the right side is equal to the left side. Mostly.
So it's not exact.
Not exact, but we call that bilateral symmetry. All right. So, here's what's nice. I'm not going to have to generate any more points. I'm going to reflect. So, for example, this point is 1 unit away from the y-axis. So is this one. This one here is 2 units away from the y-axis, which means I'm going to have another point 2 units away from the y-axis. This one here is 1, 2, 3 units away from the y-axis. So I'm going to have another one that's 3 units away from the y-axis. So I'm just going to reflect to get the rest of the points. And now I'm pretty confident. Like, clearly, if I connect those points, I'm going to have a nice looking V. Okay? So use that idea of bilateral symmetry and reflection to save you some time. Okay, save you some calculation. And now once we have it, it's just a matter of connecting all the points. And there's my absolute value function. Now notice I put arrowheads on here. That's important. Make sure you put the arrowheads because it keeps going on forever and ever. And in Notability, you've got some tools that'll let you draw perfectly straight lines and make them look real nice. Okay? Any questions so far?
So they're making, when we draw the lines, they're making a point at the bottom, it's not going to be like a...
Correct. It will not be a curve. It'll be a pointy V. A curve at the bottom, what kind of shape is going to have a curve at the bottom? What's that called? Parabola. That is correct. We will get into that later this year. Actually, we'll look at that a little bit in 2.7. All right, the next thing, we're not done. Because what haven't we done yet? Found the domain and range, okay? So that's the next thing. We got to find the domain and range. So I'm just going to start off with that. Now, I'm going to give you kind of a hint on what you should look for, some verbiage that maybe will be helpful to you. Okay? For domain and range, for the domain, we're looking for walls. Okay? I'll explain that in a minute. And for the range, we're looking for floors or ceilings. If you can keep that idea, because we all know what a wall is, we all know what a floor and a ceiling is. If you can keep that idea and see if our graph has any of those things, that will clue us in on whether or not the domain or range is something other than all real numbers. If there are no walls, then the domain will be all real numbers. If there are no floors and no ceilings, then the range will be all real numbers. If there are walls, if there are floors, if there are ceilings, then we're going to have to write something down. Okay? Other than all real numbers. Now, when we talk about walls, we're talking about things like this. Right? These are walls. Walls look like this. They're vertical. So, I'm gonna try to draw a better. Let's do this as a wall. So a wall is a vertical. I'm gonna make it a vertical line. Okay. So what I'm looking for is a right wall. If I'm on this graph, does this graph ever stop moving to the right? No. Because of this arrow here, it keeps going and going and going forever. There is no right wall. Okay, let's look at the left side. Is there a left wall? It keeps going and going and going. It always crashes through this wall. There is no right wall. There is no left wall. What does that mean for our domain?
All the numbers.
Correct. The domain is all real numbers. Okay. Now we think about it the same way, and I'm just going to draw a horizontal line. I'm going to cut it right through for now. I think about the range the same way, except now I'm looking for floors or ceilings. Okay. Is there a ceiling to this graph? Because no matter how high up I go, this graph will crash through the ceiling. There is no ceiling. Is there a floor?
Yes.
Okay. There's nothing below this. There's my floor. So there is no y value that exists on this graph under here. So what we have to do, here's what it looks like. It's the floor and above. All right. And when we talk about the range, we're talking about y. In this case, we're talking about f of x. What is the smallest, what is the value of the floor? What is the y value of the floor? -4. Okay. Can the function be equal to, can the f of x ever equal -4?
Yes.
In fact, we have it up here, right? It absolutely equals -4. And it can be -4 or what? What in terms of values? The values for y can be -4 or greater than, right? They can be bigger. They can be -4 or bigger. They can't go below the floor. They're -4 or up. So how do we write that using math terminology?
All numbers all the numbers greater than -4.
Or, say it, Adam,
Equal to.
greater than or equal to -4. Okay, so all values, all y's greater than or equal to -4. Well, how that looks is this way. This problem has an f of x. It doesn't have a y. It has an f of x. So the range is f of x greater than or equal to -4. And it's because of the floor. Whenever there's just a floor, it's always going to be greater than whatever the floor value is. It sometimes could be just greater than -4. In this case, it is also equal to, because the graph actually touches the floor. It's not hovering over the floor. It touches the floor. Okay. Make sure you write f of x. I know we talked about y all through here, but the reality is there's no y technically in this problem. There's an f of x. So there is not going to be a range, a y, an f of x value that's ever less than -4. It can be -4 or up or bigger. Okay. So another way to think about this floor, ceiling, and wall thing is that they are boundaries for the graph. There is no right or left boundary. That's what the wall is. There's no right or left boundary. There is no top boundary. It keeps going up forever. But there is a bottom boundary, and I call that the floor, because there's nothing below that. That's right. Technical set notation here. I'm going to put it up here. I should have written it like this. F of x such that all values of f of x are greater than or equal to -4. That's technical set notation. So this would be the range equals. I don't care about it, though. You don't need to write it this way. This is just fine. This is just stating what variable we're talking about. This is the official set notation. And when you get to pre-calc and calculus and those kinds of things, you will have to be very specific that way. That's one of the things I'm not picky about. I don't care if you do that or not. It's fine. If you want to do it, it's fine. Go for it. Do it. But you don't have to. Okay? Any other questions? Yeah, so if we were in a situation where we had an upside down V, then we would have a ceiling. And so instead of being greater than or equal to whatever that value is, it would be less than or equal to. Yes, that is correct. Okay? Any other questions?